So this is the 20th video on rigid body kinematics. This is also in continuation of the 27th video. In this also I'll take up some more numericals on rigid body kinematics in which we'll discuss problems on pure rolling from acceleration point of view. Okay, so I'll write down the question on the board. Okay. So in both the diagrams shown, all the details are given. Diagram shown, all the details are given. Find the value A by R beta. A, beta and R will be specified in the problem by several methods. Okay. Find the value A by R beta by several methods. By several methods we have to determine the value of the quantity A by R beta. So I write down the diagram. See, I draw the diagram. Okay. This is a fixed wall. This is a fixed horizontal surface. This is a translating plank. Here we have a circular drum with C as center, R as radius. A inextensible string is tied to this. And here there is a pulley. One end of pulley is fixed to wall. This is the drum pulley plank. Okay. This moves at acceleration A with respect to ground. And here we have pure rolling taking place. Here we have pure rolling taking place. Okay. And this is an inextensible string. This is an inextensible string. This is a fixed pulley. This is a fixed pulley. Okay. And omega and beta are both anti-clockwise. Omega and beta are respectively the angular speed and angular acceleration of drum with respect to ground. Both are anti-clockwise sense. This is the complete diagram. Okay. Now the question is find the value of A by R beta by several methods. So again we can solve this problem by 4 different methods as we did on the previous question in the 27th video. There also we discussed 2 problems. The first problem of 27th video I discussed by 4 methods. And second problem of 27th video I discussed by 2 methods. This can also be solved by 4 different methods. 2 methods. We apply SRC for acceleration in ground frame. We apply SRC for acceleration in plank frame. We apply the formula beta is equal to relative normal acceleration by separation in ground frame. And beta is equal to relative normal acceleration by separation in plank frame. So 4 methods we can solve. I'll solve it just by 2 different methods. Okay. Remaining 2 you solve on your own. In case you have some difficulty, write it down in the comment box. Okay. I'll look into it and explain it. Fine. So first of all, this is the material point D of the drum, which is in contact with the material point P of the plank. Alright, fine. So now, method 1. We apply SRC procedure for acceleration between C and D in ground frame. SRC procedure for acceleration between C and D in ground frame. So we complete the rules. SP arrow C. C is a selected point. D is the other point. Okay. SP arrow C and OP arrow D. I draw the line joining C and P. SP and OP. C and D. D. Okay. Fine. Now I give the acceleration of selected point C to P. Now since we are applying acceleration in ground frame SRC, so you must know the acceleration of C with respect to ground frame. Now see, if plank moves at acceleration A with respect to ground, this string is inextensible and pulley is fixed. So to keep this length of string fixed, center should move towards left at same acceleration A with respect to ground. So ACG should be, acceleration of C with respect to ground should be A left. So I give an acceleration of A left to other point D. A. Alright. Now I see the rotation term. D moves in anti-clockwise circle with C as center and radius R. So two acceleration to be given to D, one omega square r towards C and r beta along rightward direction. Now this I take to be ET is a unit vector along tangent plane at the contact point. En hat is unit vector along normal at the contact point. The acceleration of D with respect to ground is the vector sum of these three terms. So this term along ET will be r beta minus a into ET hat plus omega square r into En hat. So this is AdG. So AdG becomes r beta minus a into ET hat plus omega square r into En hat. And now acceleration of Planck with respect to ground, APG. Now P is a material point of translating Planck. So all locations of Planck have the same acceleration. So Planck has an acceleration of a rightward. APG also becomes AET hat. So this becomes APG. Now here pure rolling taking place. So component of ADG and APG along ET should be same from the theory of pure rolling and acceleration point of view. So for pure rolling, r beta minus a is equal to a. So r beta becomes 2a. So a by r beta becomes 1 by 2. This is therefore the required answer by method 1. Alright, fine. Now I have this one, okay. Now I discuss by method 2. Method 2, what I do, I apply the formula beta is equal to relative normal acceleration by separation in ground frame. Beta is equal to relative normal acceleration by separation in ground frame. Okay. Which to which line? To line CD. To the line CD. Okay. I draw the line joining C and D. This is C, this is D. Now acceleration of C with respect to ground, as has been explained in method 1, is simply A left. Now see, here pure rolling takes place. So acceleration of D has a component along ET, which is same as that of Planck, pure rolling. So acceleration of D along tangent plane is simply A. As I discussed here just now, r beta minus a is equal to a. R beta minus a is just a, and it has acceleration towards En omega square r. And both these accelerations, these are the normal accelerations of C and D. So normal acceleration of C is simply a, and normal acceleration of D is also a rightward. So relative normal acceleration of these two normal accelerations will be a plus a, because they are opposite direction. From the theory of relative normal acceleration between 2 points by separation r, that is just beta. That means 2a is equal to r beta. So a by r beta is equal to half, and it is therefore the required answer. So one more question I have discussed. Okay, fine. Alright. Now I take up one more question on this. Okay. So this one I'll rub it. Okay. This I'll rub it. I take up another question, part B of another question. See, another question is this. There is a fixed ceiling. Here we have a fixed pulley P1 with center C1 and radius R. And here inextensible string is folded on this cylinder. And here we have another cylinder with center at C2 and radius 2R. Okay. This center C1 of pulley P1 is fixed. This is an inextensible string. Center C2 moves downward at constant acceleration A with respect to ground. Angular acceleration of the upper pulley is beta with respect to ground in anti-clockwise sense, and angular acceleration of this lower pulley P2 is given to be 3 beta with respect to ground in clockwise sense. These are all given. All these quantities are with respect to ground. Okay. Now one more thing you must note. As center C2 moves downward, this string unfolds over this. That is, length of this vertical segment of the string goes on increasing. Alright. Length of the vertical segment of the string goes on what? Increasing. Length of the vertical segment of the string goes on increasing as the string unfolds, as the center C2 moves downward. Now here also there is no slip. No slip between the string and the drum in contact. We should write simply as NS, short form. And here also there is no slip between the string and this pulley in contact. This also we denote by NS, no slip. Okay. Now what we have to do, again we have to determine the value of the quantity A by R beta. All A beta are with respect to ground. Okay. Also it is given that at this instant angular speed of this is omega and of this is 3 omega. No, like this, sorry, like this. Both are clockwise and this is both anti-clockwise. All are with respect to ground. Okay. Now again at this we have no slip. It is given. Fine. Now this one is for the other bit. Okay. So again, you can solve this problem by several methods. For example, we are applying SRC procedure for acceleration in ground frame. You can apply in disc frame also, but they are rotating frames. So the many terms will come, so you can avoid that. That becomes quite lengthy. Or you can apply that formula beta is equal to relative normal acceleration by separation. That also we can apply. So I'll solve this by two different methods. Method 1 I'll discuss. Method 1, apply SRC procedure for acceleration in ground frame. By applying SRC procedure for acceleration in G frame. Okay. By applying SRC procedure for acceleration in G frame. Now here see, here this point D1 is in contact with the point S1 of the string, and here a material point D2 of the lower drum is in contact with material point S2 of the string. Okay, and both these points we have no slip we are given, because and no slip at these 2 points we are given. So now what we have to do? What we have to do is apply no slip here and no slip here, and then A by R beta value will be determined. So first of all, see, here we have to apply no slip between D1 and S1. So first we must know the accelerations of D1 and S1. Okay. So now see, D1 is the material point of this pulley P1 whose center C1 is fixed. So D1 moves in a circle with center at C1 and radius R. From the theory of circular motion kinematics of point, acceleration of D1 will have two components. An acceleration omega square R towards center C1 of the pulley P1 and downward acceleration R beta. Downward acceleration to the point D1 R beta in downward direction. And here the string and pulley there is no slip. So acceleration of this point S1 of the string in tangent plane will also be R beta. Okay, because of no slip condition here in tangent plane these 2 points will have the same acceleration. Now this string is inextensible. So acceleration of S1 S2 should be equal. So acceleration of S2 should also be what? In this direction should be R beta. Okay. Now what you have to do, you consider the lower pulley. Okay, fine. You consider the lower pulley. Now here you see, here also there is no slip. This is the point D2 of the lower pulley which is in contact with material point S2 of the string. Now here also it is no slip. So in common tangent plane D2 and S2 will have the same acceleration. So acceleration of D2 in common tangent plane will be how much? R beta in downward direction. Okay, fine. And D2 will also have some acceleration towards center C2 of the pulley. That will be omega of this pulley, which is how much? 3 omega. And radius is how much? 2r. 3 omega whole square into 2r. Okay, so acceleration of d2 is the vector sum of these two. 3 omega whole square into 2r and r beta in this direction. Alright, fine. Is it clear? Now what I do, I apply SRC procedure for acceleration between C2 and D2 in ground frame. So SRC procedure for acceleration in ground frame between the points C2 and D2. So SP arrow C2, OP arrow D2. Okay, SP arrow C2 and OP arrow D2. So देखिए, now what I do, I draw the line joining C2 and D2. So this is the line joining C2 and D2. Okay. Now I give the acceleration of C2 to D2. Acceleration of C2 with respect to ground is A. So I give acceleration A to D2 in downward direction. Now I write down the sentence. D2 moves in a clockwise circle with center at C2 and angular velocity how much? 3 omega. And angular acceleration how much? 3 beta, both in clockwise sense. So two accelerations I give to D2. First I give 3 omega whole square into 2r because radius is 2r. And second I give what? 3 beta into 2r in upward direction because 3 beta is clockwise. So this is how much? 3 beta into 2r, 6r beta in upward direction. Alright, 3 beta into 2r, that is 6r beta in upward direction. So acceleration of d2 is the vector sum of these three terms. Now in the common tangent plane at the contact point, here also there is no slip. So in the common tangent plane at the contact point, acceleration of s2 and d2 along tangent, that is along downward direction, should be equal. So in downward direction, acceleration of d2 is how much? A minus 3 beta into 2r, 6r beta. That is just equal to this r beta, this point, r beta. So A is equal to 7r beta. So A by r beta is equal to 7. A by r beta is equal to what? 7. This is the required answer, okay? So A by r beta is equal to 7. This is therefore the required answer. Alright, fine. This answer we have obtained by method 1. So in this we applied SRC procedure to both the pulleys in ground frame. We applied SRC procedure for acceleration between points C1 and D1 to pulley P1 in ground frame. And we applied SRC procedure for acceleration between the points C2 and D2 to pulley P2 in ground frame. And from this we obtained the answer A by r beta is equal to 7. Okay. Now we can solve this by method 2 also. Method 2 also I'll solve it. Method 2 what I'll do? I'll apply the formula relative normal acceleration by separation in ground frame. And that from there also we can get the answer. Alright. So this I rub it now. Fine. So method 2, we apply the formula beta is equal to relative normal acceleration by separation in G frame. Okay. So first part of method 1 I use some results of method 1 I use directly use here. Okay. So this we found that acceleration of this point d1 in downward direction is r beta. So of this point is also r beta. So this point is also r beta. So this point is also r beta because of that pure rolling no slip condition. So I draw the line joining C2 and D2. Sorry, D2 and C2. C2 acceleration is how much? A in downward direction. And acceleration of D2 is what in downward direction? How much it is? Why? That is equal to that of S2 in downward direction. And that of S2 is same as S1 in downward direction. And that of S1 is same as D1 in downward direction. But D1 in downward direction is how much? R beta. So S1 downward is also how much? R beta. So this point S2 downward is also how much? R beta. So this point D2 is also how much? R beta. So here also it is what? R beta. This distance is how much? 2R. And angular acceleration of this line is how much? 3 beta of this pulley. So both these normal accelerations of C2 and D2 are A and R beta respectively. They are in same direction. And beta is 3 beta is in clockwise sense. So for beta we write 3 beta. This formula for beta we write 3 beta to V2. So 3 beta. That is equal to relative normal acceleration by separation. Relative normal acceleration by separation. So normal expressions of C2 and D2 are A and R beta respectively. Okay. So relative normal acceleration becomes how much? Either A minus R beta or R beta minus A. Now which one should you write? R beta minus A or A minus R beta? If you write R beta minus A, then we mean that R beta should be more than A. Then rotation beta would be in anti-clockwise sense, but it is in clockwise sense. So you must not write R beta minus A, you must write A minus R beta. So it will write as A minus R beta by 2R. So this means A minus R beta is equal to 6R beta. So this means A is equal to 7R beta. So this means A by R beta is equal to 7, which is therefore the required answer. So this also second question, this part B of question also has been solved by two different methods. Okay. So in both these methods, same answer has been obtained. It should be okay. So this was the 20th video on rigid body kinematics. Fine. In next video also, I'll take up some more problems on pure rolling from acceleration point of view. Okay. And then after finishing that chapter, I'll pass over to that IC concept. Okay. So you go through these videos properly, understand it everything. In case you have doubt, you write down in the comment box. I will communicate it to you. Fine. Through my reply. And you must and you understand all them thoroughly. You don't have to go anywhere. It's more than sufficient for JEE Mains Advanced everything. If you properly understand these videos, you are through. You don't have to go anywhere. You don't have to take up any of the books theory. You must read this much. That's more than sufficient. Okay. So I close it here. Fine.